In today's video, I would like to introduce you a very nice problem of Moroccan Mathematical Olympiad edition 2021. Here is the following information. Find the greatest value of n as a natural number such that we have square root of m is not natural number. Okay, but m is natural number. We have this following equation: square root of n plus square root of n plus 60 equals square root of m. Okay, so if you take a look carefully at this expression, the right hand side of this equation is written in terms of m, but the left hand side of this equation is written in terms of n. So the question, we are going to find the maximum number of n which verify this equation. Okay, as n is increasing up, and also m must be increasing up. Okay, so as you changing the value of n up, m must be changed as well. Okay, so the relationship between n and m is built by this equation. Okay, I would be recommended to give that a try to this problem before you get into the solution. By the way, don't forget to support us with your like and subscribe. Now let's go ahead, jump into the solution. We have this following setup. The trick that I'm going to use now, I'm going to multiply numerator and denominator by square root of n minus square root of n plus 60. So we'll have square root of n minus square root of n plus 60 is multiplied by square root of n plus square root of n plus 60 is divided by square root of n minus square root of n plus 60. Okay, so the whole thing equals square root of m. Okay, so by simplifying out this expression, square and square root of n will be cancelled out each other. I will get n. The same thing with the n square root of n plus 60. I will get n plus 60 is divided by square root of n minus square root of n plus 60 equals square root of m. Okay, so this n will be cancelled out. I will be left with minus 60 over square root of n minus square root of n plus 60. I'm going to switch these two terms and cancel out the minus sign from numerator and denominator and multiply side by side. I will get square root of m is multiplied by square root of n plus 60 minus square root of n equals 60. Okay, so I have ended with this expression. Now I'm going to check the cases. Here is the thing: square root of m equals to this term. That means square root of m is bigger than this term. Also, square root of m must be bigger than this term because square root of m equals the whole thing. But here we have the minus sign. That means square root of m is strictly superior than this term. Okay, so the thing here, but square root of m is not a natural number. Okay, so I'm going to transfer this one into square root like this. Okay, so we'll have square root of m is multiplied by square root of n plus 60 minus square root of n. We must write 60 as this form. Okay, square root of m. Like I can write this one on this form. Square root of 2 is multiplied by square root of 30 is multiplied by square root of 30. So I cannot write square root of 60 is multiplied by square root of 60 because we don't have equality here. So also we have another possibility. We have 4 is multiplied by square root of 15 is multiplied by square root of 15. Because square root of 15 is multiplied by square root of 15 is 15. 15 is multiplied by 4 is giving us 60. Okay, and also can rewrite it as 6 is multiplied by square root of 10 is multiplied by square root of 10. Because 10 is multiplied by 6 is giving us 60. And also I can rewrite it on the other form as well. 12 is multiplied by square root of 5 is multiplied by square root of 5. And also I can rewrite it as 20 is multiplied by square root of 3 is multiplied by square root of 3. Square root of 3 is multiplied by square root of 3 is 3. 3 is multiplied by 20 is giving us 60. Now if I'm going to go through all these cases, it will be a lot of work. Okay, it will be too many cases. We cannot go like this. We cannot work like this. I'm going to add this one. Square root of m is always bigger than this term. Square root of n plus 60 minus square root of n. Okay, that's mean square root of m is taking the bigger number. this term is taking the smaller number. Okay, we are going to make the comparison which one is the most biggest one here. Okay, so the most biggest one here is this one. If you calculate this term, is giving us like 34 point something, because 20 is multiplied by 1.7, because m is taking this one, because this one is square root of m. Okay, because this one is bigger. This one is almost 34 point something. Okay, this is the biggest value comparing with other numbers. Okay, so we have this one. The second one is this one. All these terms are smaller than these terms. Now what we are going to do, I'm going to check first with this one. If this one doesn't work, then we move on to the lower one, which is smaller than this one. Okay, if we found the solution here, we don't need others. Okay, let's check with this one first, because I'm not going through all the cases. I'm going to take this one as square root of m. So I will have square root of m. I'm going to write this one as it by taking square root of m as this value. So we'll have square root of n plus square root of m, square root of n plus 60 equals square root of m, which equals 20 square root of 3. Then I'm going to use this fact. If this square root of m is taking this one, that means this term is taking this one. Okay, so square root of n plus 60 minus square root of n equals square root of 3. By making the combination between first and second equation, I'm going to take this value and insert it in the second equation. By doing that, I will have this term equals this term minus square root of n. In the other word, I will have 20 square root of 3 minus 2 times square root of n equals square root of 3. Okay, by moving over this square root of 3 to the left and move over this term to the right, I will get 19 square root of 3 equals to square root of n. So then I'm going to divide both sides by number 2. If you are going to square both sides, you will get n, not an integer. Okay, because we have fraction is not an integer here. This one is ruled out of this possibility. Okay, it's not necessary. If you will find the solution in this one, then you move on to the lower one, but we'll have another possibility. Now this time I'm going to switch these numbers. I'm going to put square root. I'm going to put this one as 10 is multiplied by square root of 3 and is multiplied by 2 is multiplied by square root of 3. Okay, by taking this value as a square root of m. Okay, then the other one is taking this term, then this one is taking the value of this one. Okay, so I'm going to do the same job here. Square root of m will be taking 10 square root of 3. Okay, then this term is taking 2 times square root of 3. By combining these two equations, I'm going to insert this one with this value. This one is giving us 10 square root of 3 minus square root of n, which is, I will get 10 square root of 3 minus 2 times square root of n, as I did before, equals 2 times square root of 3. Okay, by moving over the terms, I will get here 10 minus 2, which is 8 square root of 3. By moving this one to the right side, I will get 2 is multiplied by square root of n. So by dividing both sides by 2, I will get here 2 will be cancelled out. Then 8 becomes 4. I'm going to square both sides. I will get 16 is multiplied by 3, which is 48. 48 equals n. This is the biggest value. Okay, now we need only one thing to check. If this one bigger than this one, we must check this one as well. Mimi has the solution bigger than this one. Okay, 10 is multiplied by square root of 3 is giving us almost around 17, but this one is bigger than this one because we have square root of 5, 2 point something is multiplied by this one is giving us around 24. We must check this one as well. So by doing that, by taking this one as a square root of m, the same thing here, I'm going to switch just these values. Instead to have 10 square root of 3, I will have 12 square root of 5. So I have 12 square root of 5 minus 2 times square root of n equals, I will have square root of 5 here. Okay, so by taking this term to the left and move over this to the right, I will get here 11 square root of 5 equals 2 square root of n. This is impossible because the left hand side of this equation is odd, the right hand side of this equation is even. That means this one is impossible to have these values. That means 12 square root of 5 is ruled out of this possibility. Let's check another case. Now let's check this one. If we have 6 is multiplied square root of 5 is multiplied by 2 square root of 5. Okay, by putting this one as a square root of m. Okay, by taking the value which is less than the previous one, I'm going to compare the previous one and this one. As we have before, this is around 17, but this one is giving us around, this is almost 2.5 is multiplied by 6 is giving us around 15. That means this value is always bigger than this value, so we don't need to take this value. This is the bigger value of n which verify this equation. So with square root of m equals 10 square root of 3, which is not an integer. I have done this problem. If you are interested in watching this one, don't forget to support us with a like and subscribe. Thank you for watching. I will see you next video. Bye.